Parallel universes. Are we living in a multiverse? Hey there, space enthusiasts. Ever gazed up at the night sky and wondered, is our universe the only one out there? Well, grab a comfy seat and maybe a cup of coffee, because today we're diving into one of the most mind-bending ideas in science, the multiverse. So, what's the deal with parallel universes? Is it just science fiction, or could there be some truth to it? Let's embark on this cosmic journey together. We'll explore different theories that suggest other universes might exist, the evidence supporting them, or lack thereof, and what it all could mean for us mere mortals. Ready? Let's go. First off, let's get a grip on what we know about our own universe. You might have heard the term, observable universe. It's basically the part of the universe we can see or detect, limited by the speed of light. Since the universe is about 13.8 billion years old, we can only see light that's had time to reach us since the Big Bang. Think of it like being at the center of a bubble, our cosmic horizon. Beyond that, it's uncharted territory. But here's the kicker. There's no reason to believe the universe just stops beyond what we can observe. It's entirely possible, likely, even, that the universe extends far, far beyond our cosmic horizon. There could be regions of space we can't access, filled with galaxies, stars, maybe even other forms of life. Kinda humbling, right? Our tools and senses are pretty amazing, but they're not infinite. We're like fish in the cosmic ocean, unaware of what's beyond our little reef. So, what if there's not just more universe out there, but entirely separate universes? Let's dive deeper. The idea of multiple worlds isn't new. Philosophers like Democritus and Epicurus in ancient Greece pondered infinite worlds way back when. They mused about an endless cosmos with countless atoms forming countless worlds. Pretty ahead of their time, if you ask me. As science progressed, especially with advances in astronomy and physics, these musings evolved from philosophical thoughts to scientific hypotheses. The more we learned, the more we realized how much we didn't know. Alright, let's get a little quirky with quantum mechanics, but don't worry, we'll keep it chill. At the tiniest scales, particles don't behave like anything we experience in daily life. They can exist in multiple states at once, a concept called superposition. They can be entangled, influencing each other instantaneously over distances. Wild, huh? Enter Schrödinger's cat, a thought experiment. Imagine a cat in a box with a radioactive atom that can either decay or not, triggering a poison. Until we check, the cat is both alive and dead. It's a way to illustrate superposition with something we can wrap our heads around. Hugh Everett III, in 1957, took this a step further. He suggested that instead of the cat being in a superposition, both outcomes happen, but in separate, branching universes. Every quantum event splits the universe into different realities where every possible outcome exists. Think about it. There's a universe where you had cereal for breakfast and one where you had toast. Infinite versions of you making every possible choice. Mind-blowing, right? Switching gears to the cosmic scale. Right after the Big Bang, the universe underwent a massive growth spurt called inflation. It expanded faster than the speed of light, which is okay in this context. This helps explain why the universe looks pretty much the same everywhere we look. But some theories suggest that inflation didn't happen just once. It might be eternal, happening in different places at different times, creating multiple bubble universes. Imagine each bubble as its own universe, potentially with different physical laws and constants. Our universe? Just one bubble in a vast cosmic soda pop. There's even speculation that these bubbles could collide, leaving imprints or anomalies in our universe. Scientists have searched for these signs in cosmic background radiation, though so far, evidence is elusive. Now, let's talk strings, not the ones on your guitar. String theory posits that the fundamental particles aren't zero-dimensional points but tiny one-dimensional strings, vibrating at different frequencies. For the math to work, it requires extra dimensions, up to 11. The equations of string theory have a mind-boggling number of solutions, like 10 to the power of 500 different ways to compactify those extra dimensions. Each solution corresponds to a different possible universe with its own laws. So, these other universes could exist in dimensions folded up so small or so different from ours that we're unaware of them. Or maybe they're separated by higher dimensions we can't perceive. Getting philosophical again, hang tight. Physicist Max Tegmark proposed that mathematical structures don't just describe reality, they are reality. That means every mathematical possibility corresponds to a physical universe. He outlines 4 levels. Level 1. Regions beyond our cosmic horizon, pretty standard. Level 2. Universes with different physical constants, thanks, eternal inflation. Level 3. The many worlds interpretation, hello, quantum splits. Level 4. The ultimate ensemble of all mathematical structures. This unifies the multiverse concepts and suggests that anything that can exist mathematically does exist physically somewhere. It's like the ultimate, everything bagel, of universes. Alright, time to address the elephant in the room. The big issue with multiverse theories is that they often aren't testable. We can't, currently, observe other universes, so how do we prove they exist? Scientists look for indirect clues, like anomalies in the cosmic microwave background radiation, the afterglow of the Big Bang. Patterns or cold spots might hint at interactions with other universes, but so far, nothing conclusive. Many in the scientific community argue that a theory that can't be tested isn't really science, it's metaphysics. They caution against venturing too far into untestable speculation. Yet, the mathematical frameworks supporting these theories are robust. They elegantly solve problems and unify concepts. It's a delicate balance between following the math and demanding empirical evidence. If the multiverse is real, it challenges our understanding of reality. There could be infinite versions of you living out every possibility. It's both exciting and a tad unsettling. If every choice spawns another universe, what does that say about free will? Are we just one of many iterations? Do our choices matter more or less? This principle suggests that the universe must be compatible with conscious life, because we're here to observe it. The multiverse adds context. Maybe countless universes exist, but only some support life like us. If all outcomes happen somewhere, how does that affect morality? Does it make our actions more significant because we can shape this version of reality, or less so because every alternative also exists? Let's lighten things up. Writers have had a field day with parallel universes. From The Chronicles of Narnia to His Dark Materials, stories explore alternate realities, allowing us to ponder what-if scenarios. Movies like Interstellar, Doctor Strange, and the entire Marvel Multiverse saga bring these concepts to life on the big screen. They make complex ideas accessible and super entertaining. Artists and philosophers draw inspiration from these ideas, pushing the boundaries of creativity. The multiverse sparks imagination, encouraging us to think beyond our everyday experiences. So, what's next? New telescopes, like the James Webb Space Telescope, and particle accelerators may provide more insights. As our tools improve, so does our ability to test these theories. Scientists worldwide are teaming up, because big questions require big collaborations. Projects like CERN and space agencies are crucial for advancing our understanding. Perhaps breakthroughs will come from unexpected places, a new theory, a surprising observation, or a genius mind thinking outside the box. The future is wide open. Wow, we've covered a lot, haven't we? We've journeyed from the limits of our observable universe to the mind-bending possibilities of quantum mechanics, cosmic inflation, string theory, and the mathematical multiverse. Whether or not the multiverse exists, contemplating it reminds us of how much we have yet to learn. It's humbling and exhilarating to think about our place in the grand scheme of things. So, next time you look up at the stars, imagine the possibilities. Maybe there's another you out there making different choices, or entire universes with laws and realities beyond our wildest dreams. As the great physicist Richard Feynman once said, "I think nature's imagination is so much greater than man's, she's never gonna let us relax." Let's keep asking questions, stay curious, and enjoy the wonder of exploring the unknown together. Thanks for hanging out, and until next time, keep looking up.